right, well, let's jump into it. What I wanted to discuss this evening was two things. First of all, the arrangement of objects in a row, because they love that for fundamental counting principle. And then the other thing that I wanted to bring into the fundamental counting principle was the idea behind probability. Okay, so where we would calculate the probability of a particular thing happening. Okay, so to explain the arrangement of objects in a row, I'm going to use this example. All right, so in the first sentence, it says to us, in how many ways can 3 boys and 2 girls sit in a row? Now, remember, people cannot be repeated like letters or numbers. All right, so people are obviously unique, so we would have to use factorial notation in this way. What do you guys think? In how many different ways can 3 boys and 2 girls sit in a row? What do you think we would have there? What do you guys think? In how many ways can 3 boys and 2 girls sit in a row? There we go, Lesejo. Good, well done. So Lebogang, remember we're trying to fill 5 blocks. Okay, so if we fill 5 blocks, let's get them on the screen. Okay, that's it, Leanne, 5 factorial. Because there are 5 people to fill the first seat. That means there are 4 people left over to fill the second, 3 people to fill the third, 2 people to fill the second, and only 1 person left standing to fill the last. So it would be 5 factorial ways. Okay, so that would be 120 different ways that they could fill those seats. All right, in B, in how many ways can they sit in a row if a boy and his girlfriend must sit together? All right, so what you see now, Lebogang? All right, so now there's a condition placed on this. A boy and his girlfriend have to sit together. So what we do is this. We put the boy and his girlfriend together, but they could also sit girl, boy, like that. So there are 2 factorial ways in which a boy and his girlfriend can sit with each other. And then we put them together as a group. If a boy and his girlfriend sit together, it means that there are 2 other boys and 2 other, oh, sorry, I'm writing B when I'm saying girls. 2 other boys and 2 other girls that are left over. And we treat each one of these as their own thing that this pair can be combined with. So it would be 2 factorial by 1, 2, 3, 4, 5 factorial, because there are 5 factorial ways that the boy-girl combination can be arranged with everybody else. So this would be 2 factorial by 5 factorial. Does that make sense to everybody? Okay, so Leanne, you said 2 factorial by 4 factorial. Okay, I'll go through that again. This is a little bit more difficult, isn't it? Okay, so let's start again. All right, remember, we have 5 people, okay? 3 boys and 2 girls. Oh, sorry, I made a mistake there. Sorry. I see what I did wrong. I had too many people. Beg your pardon. Sorry, it's 3 boys. So we've got a boy and his girlfriend that want to sit together. So they can sit boyfriend, girlfriend, or they can sit girlfriend, boyfriend. Then what we do is we put them together as a group. Okay, when we combine them with all the other ways in which they can sit with the other people. So there are 2 factorial ways that they can sit with each other, boy, girl, or girl, boy. Okay, now how many boys are left over? 1 boy is already gone. So there are 2 boys remaining, sorry, and 1 girl. All right, so then we treat each of them as their own object with which we can alternate the boy-girl combination. Okay, so that's why we would say by 1, 2, 3, 4 factorial ways they can sit with everybody else. Okay, so this is 2 factorial by 4 factorial. Sorry, you were quite right. Sorry, I thought there was an extra girl. Okay. Right, so that gives us 48 ways. All right, question C. In how many ways can they sit in a row if the girls and the boys are to sit next to each other? So in this situation, we either have boy, 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 girl, girl, or we're going to have girl, girl, boy, boy, boy. All right, so all the boys have to be together and the girls have to be together. So when the boys are together, there are 3 factorial ways that the boys can sit with each other. There are 2 factorial ways in which the girls can sit with each other. And then there are another 2 factorial ways in which they can sit. So it's either boy, 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 girl, girl, or girl, girl, boy, boy, boy. All right, so that would be 3 factorial by 2 factorial by 2 factorial, which I think is the same as B. Okay, so it would also be 48 ways that they can sit together. That's it, Pumzile, quite right. Okay, then in part D, it says, in how many ways can they sit in a row if just the girls are to sit together now? What do you mean, what about the last 3 boys?
Ma'am, you said you said they can sit in 3 different ways in the first
Yeah,
seat.
so that's right. So the boys can sit together in 3 factorial ways.
And then the second time it's the girls that can sit in 2 different ways. And then what about the 3 B's at the end in the second row?
Oh no, this is exactly the same thing. All right, so I've taken
Okay.
that I've taken that into account when I've done this over here. I think what I did do wrong, sorry, is that it would be 2 factorial by 2 factorial is 4. Sorry, this should be 24. Sorry. Where I'm being a bit dilly today. There we go. That should be the 3 factorial by 2 factorial by 2 factorial is correct. It should be 24 ways in which they sit together. Okay, that is correct. All right. Why 3 factorial? Because in Nhlanhla, there are 3 factorial ways in which the boys can sit with each other. Okay, remember these are 3 different boys. Okay, so when one boy sits down, there's a choice of 3 to fill the first seat for the boy. Then if a boy is sat down, there are 2 boys left over. Then if that boy sits down, there's 1 boy left standing. So there's 3 factorial ways in which the boys can sit with each other. Okay, does that answer your question? So what you've got to first consider each time matrix is the number of ways in which they can sit with each other. Then you put them together as a group, and then you consider the number of ways in which they can sit with the other people as a group. Does that make sense? Okay, so it's the same thing with the boy and his girlfriend. Okay, so when we think about the boy and the girl, they can sit together, boy, girl, or girl, boy. That's why it's 2 factorial ways. Then we put a circle around them. They're now a group. In how many ways can they sit with everybody else? Okay, so we count them as a group, and then we count the other people that they could be combined with. All right, and then that would give us by 4 factorial. Okay. Oh, good. Oh, I'm glad you're understanding. Great. Now it says, in how many ways can they sit in a row if just the girls are to sit together? Okay, so now we've got girl, girl, all right? There are 2 factorial ways in which they can sit with each other. Okay, they're 2 different girls. And then we've got a boy and another boy. So they can sit with the others in 4 factorial ways. 1, 2, 3, 4 factorial ways. Okay, so it's going to be 2 factorial by 4 factorial. So it will also be 48 ways in which the 2 girls can sit with each other. That's it, Leanne. Well done. Okay, and then question E says, in how many ways can they sit in a row if just the boys are to sit together? So now we've got boy, boy, boy. They can sit together in 3 factorial ways, and then we've got girl, girl. So that would be 3 factorial by 3 factorial.
Ma'am,
Yes.
where by the one that you just did before the boy, boy, girl, where it's like 2 factorial times 4 factorial, why is it 4 not 3?
Okay, because there are 4 groups. There's the group with girl, girl, and then there is the boy and another boy.
Okay, thank you.
Okay, no problem. All right, so the first number that I wrote there, the 2 factorial, is the number of ways in which the 2 girls are sitting together. Then the 4 factorial represents the way that the group of the 2 girls is combined with everybody else. Okay, so with the other 3 boys. Okay. All right, and then the last question, F. In how many ways can they sit in a row if the boys and girls are to alternate? Okay, so there is only one way that that can happen, right? Because there are 3 boys and 2 girls. So the only way that this can happen is if there is a boy and then a girl, and then a boy and then a girl, and then a boy. Okay, so the only way that they can sit in a row with the boys and the girls alternating is boy, girl, boy, girl, boy. So Leanne is saying 5 factorial. It's not 5 factorial. One by one by one. Good try, but that's not it either. Lindelwa, you're very close, but you used the wrong sign. Now, you can't divide in this case. All right, because we're not trying to get rid of anything. Okay, now I want to stop you there. Both Lindelwa and Mamelo have used 3 factorial. Where does your 3 factorial come from? Can you explain that, where your 3 factorial comes from? Okay, so you know what's another way for you to think like this? Okay, all right. Let's try and fill the boxes and see whether that helps you guys a little bit. All right. So we know that the first seat, the first place over here, all right, has to be filled by a boy. How many boys do we have to choose from? With 3 boys, okay? So there are 3 ways in which we can fill the first seat, okay? There's a boy who's now sat down. In the next seat, there has to be a girl, okay? How many girls do we have to choose from? 2. So there's 2 ways that the seat can be. Now remember, we've got rid of a boy, we've got rid of a girl. In how many ways can we fill this seat over here? Remember, it has to be a boy. Good, well done. There are 2 ways. Now we've got another boy gone. In how many ways can we fill this final seat over here? Has to be a girl, only 1 way, because there's only 1 girl left. All right. Then there's only 1 way in which we can fill that seat over there. Okay, so 3 by 2 by 2 by 1. So the other way that you could write this, all right, if you've got 3 by 2 by 2 by 1 by 1, you could write this as 3 times 2 times 1 times 2 times 1. Okay, so the last 2, that's this 2 over here, and that 1 over there is going over here. So we've got 3 factorial by 2 factorial. Okay, or you can just say 3 by 2 by 2 by 1 by 1. It's exactly the same thing. Does that make sense to everybody? Okay, so 3 by 2 by 2 by 1 by 1. So yes, Leanne, there are 12 ways in which that can happen. Okay, all right. So if in doubt, try and use the boxes and do what I showed you with question F. All right, because I think filling those boxes like that is a very useful tool to help you answer the questions. Do you agree?
Yeah, I think it's the easiest way. Yeah. I think that I agree with
Yeah.
you, Teacher Lee.
Yeah. Yes, I am sure about E's answer. If you want me to go through how I calculated it again, I'm happy to do that. Not to say that I don't make mistakes, because I certainly do, but I am certain I've done that one correct. Teddy, do you want me to explain it again?
Yes,
I
please,
don't.
ma'am.
Okay, Teddy, not a problem. All right. So the question asked us in E, in how many ways can they sit in a row if just the boys are to sit together? So let's just, that was this one over here. Let's just get rid of that. Okay. So now the boys have to sit together, Teddy. All right. So we've got to have boy, 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 like so. So when we put them together as a group like this, we say, because there are 3 boys, there are 3 factorial ways that the boys can sit with each other, right? They're now a group, and now we've got to consider how they can sit with the other 2 girls. Okay, so what you do now is you count how many circles you've got. Okay, so there are another 1, 2, 3 factorial ways in which they can be arranged with the girls. Okay, because you can have the 3 boys first, then you could have the 3 boys in the middle and a girl on either side, or you could have the 2 girls first and then the 3 boys at the end. Does that make sense? That's why it's 3 factorial ways in which they can sit with everybody else.
It
Does that
does,
make
ma'am.
sense?
Thank you.
Okay, all right. You understand now. Okay. All right, cool. Please don't do what Teddy did. Don't be afraid to stop and say, am I sure, or have I made a mistake? I do make mistakes, and I'm certainly not going to say that I don't, and I don't mind if you stop me and ask me if you're not sure about something I've done. Okay, so let's have a look at a couple of different questions that they ask us. I'd like to do question number 1 with you, and then we're going to talk about some books, because they like to organize books in a row as well. So let's just look at question 1A and B for now. Okay, so question 1A says, in how many ways can 9 people be seated in a row of 9 chairs? This is a bit easier. There we go, 9 factorial. Okay, so 9 factorial gives us how much? Sure, quite a lot of ways. Okay, so 3, 6, 2, 8, 8, 0. All right, cool. All right, we're all in agreement. B, in how many ways can 20 people be seated in a row of 20 chairs? Well, that's also fairly easy. Exactly, Pumzile, 20 factorial. Okay, that must be a big number. Yeah, we're not even going to worry about writing that out because that is huge. Okay. Let's go and have a look at the questions about the books. Okay, so in question number 4, let's look at this one now. Question 4. 4 history books and 3 geography books must be placed on a shelf. So in how many different ways can you arrange all the books on a shelf? What do we think? So there are 4 history books and 3 geography books. They're going to be placed on a shelf. And how many different ways can you arrange them on the shelf? 4A. Okay. Books don't have to necessarily be next to one another. That's it. Okay, Pumzile, quite right. Right, so this would be 7 factorial because we're not saying that the books have to be arranged next to each other. So it would simply be 7 factorial ways, which would give us 5040. That's it, Akila. All right, in the second question, it says, if all the history books must be placed next to each other and all the geography books must be placed next to each other, in how many ways can we arrange them on the shelf? So now, history and geography want to go together. How many ways can we arrange them on the shelf? There we go. All right, so Pumzile and Nhlanhla both giving answers for us over there. All right, so we want history, 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 and history together, and geography, geography, geography together. So when we put a circle around the history books, there are 4 factorial ways in which they can be arranged with each other. Then as far as the geography books are concerned, there are, not 2, 3 factorial ways in which they can be arranged. That's it, Akila, quite right. And then we can have the history group first and then the geography group, or the geography group first and then the history group. Okay, so that's why there would be another 2 factorial. So you guys are quite right. 4 factorial by 3 factorial by 2 factorial. Okay, so 288 different ways that the history books and the geography books can be arranged with each other. Good. All right, let's have a look at question C. If just the history books are to be together, in how many ways can you arrange the books on the shelf? So we just want the history books together. Okay, so Nhlanhla says 4 factorial by. Okay. You thought about that again. Okay. So the history books are to be together. In how many ways can you arrange the books on a shelf? Okay, so that's the number of ways in which the history books can be arranged with each other. Because remember, we're going to put them together and then we're going to put them in a group. So there's 4 factorial ways in which they can be arranged with each other. But there are 3 other geography books floating around. Okay, that's it in Nhlanhla. So it will be 4 factorial by 4 factorial. Does that make sense to everybody else? Is that making sense to the rest of you? Yes, 576 is quite right. Okay, but Lesego, let's go back again. Okay, Lebogang and Pumzile, not a problem. Let's just talk about it again. So remember when we were talking about the boys? okay, and the girls sitting together. So if we take this example over here, why is it 3 factorial by 3 factorial? Because there are 3 factorial ways in which the boys can sit with each other as a group. And then you've got 1, 2, 3 groups. Okay, so that's 3 factorial ways in which the groups can be sat next to each other. So it's exactly the same thinking over here. You've got 4 factorial ways in which the history books can be arranged with each other. Put them together in a group. Then you've got 1, 2, 3, 4 groups. So there are 4 factorial ways in which they can be arranged. Okay, so another way to look at it, probably would have been easier with the boys and the girls, but you can either have the 4 history books together, and then you've got geography, geography, geography. Then what you could do is you could have a geography book at the front, the 4 history books over here, and then 2 geography books over there. And then they slide down. So then you could have 2 geography books. Okay, and then the 4 history books. Okay, and 1 geography book at the back. Or we can have the geography books all at the front and the 4. Okay, so that's why it has to be 4 factorial by 4 factorial. Because there are 4 factorial ways that the history books can be together by 1, 2, 3, 4 factorial ways in which they can be arranged with everybody else. Okay, maybe your teachers have shown you that at school where it slides down in a row like that. Okay, you see now. All right, that's fine. Okay, sometimes just looking at it from a different perspective helps. Okay. All right, so let's go and have a look at some of the other questions that we have here. So let's look at question number 7. All right, so in how many ways can 3 South Africans, 4 Americans, 4 Italians, and 2 British citizens be arranged so that those of the same nationality sit together if they sit in a row? So I tell you what, take a minute, read the question, try it on your own. Okay, then you can send Yolanda and I what you think the answer is, and then we'll talk about it. So just think about this one and see if you can do this one on your own. Okay. Let's see what you guys are saying. Okay, so Yolanda. Yes, it is. Okay, so Yolanda, you've sent me the right answer. Lesego, I'm just checking yours. Yes, Lesego, you've sent me the right answer. Okay. Nhlanhla, one of your values is wrong. Maybe you just didn't look at the question correctly. Pumzile, I'm sorry, that's not what I have. And Leanne, I'm also getting a different answer from you. Okay. So what sometimes helps is to write the letters down. So let's see, Iviwe, what are you saying? Yes, Iviwe. That's it. Akila, good. Well done. That's it. Now you've got it, Pumzile. Yes. That's it. There we go. Well done. Well done, everybody. That's lovely. Yes, Mamelo. Tsepiso, perfect. Good. Yes, Awami. Nice. Good job. Okay. Very nice. Well done. Yes, Nhlanhla. Perfect. Okay, very good. So those of you that are sending me answers now, I've got it perfectly. Okay, so there's 3 factorial ways that the South Africans, okay, so Leanne, I'm going to explain it. So there's 3 factorial ways that the South Africans can sit together. Okay, there are 4 Americans, so there are 4 factorial ways that the Americans can sit together. There are 4 Italians, so there are 4 factorial ways that the Italians can sit together. And there are 2 British citizens, so there are 2 factorial ways that they can sit together. Now, remember, we're going to fix these all into their own groups. So the South Africans, the Americans, the Italians, and the British. So there are 4 groups here. So there are an additional 4 factorial ways in which the groups can be arranged with each other. Okay, so that's why it's 3 factorial times 4 factorial times 4 factorial times 2 factorial times 4 factorial. Okay, that was not an easy question. Does that make sense now, Leanne? Okay, so once you get that, it actually becomes quite easy. But it's just understanding that in the first instance. Okay, so I actually worked out what this number was earlier, and now I cleared my calculator, which was a bit silly. So it's a big number, 165,888 ways that these people can be arranged if nationalities of the same sit together. Okay, let's go and have a look at question number 8. Okay, so they're talking about golf balls and they have been numbered 1 to 12 and placed in a box. Every time a ball is drawn, it is placed on a rack, one next to each other. So you can see we're arranged them in a row. All right. In part A, it says how many different arrangements of the 12 golf balls is possible? So what do we think? How many different ways can the 12 golf balls be arranged on the shelf? Remember, we're not saying anything about even numbers need to be together or prime numbers need to be together or odd numbers need to be together. We're just arranging. There we go. Well done. So in 12 factorial ways. Okay, very good. So, wow, that is a huge number, isn't it? I think we'll just leave it as 12 factorial and not write that out. Good job, everybody. Okay. Now let's have a look at question B. The numbers 9 and 12 must be placed next to each other in any order. In how many ways can the numbers then be rearranged? Okay, so what I'm going to do is this. Okay, we're going to put number 9 and number 12 together. Okay, Pumzile is hot off the press there. Well done, Pumzile. Okay, so that is going to be 2 factorial ways in which they can be arranged with each other because the order doesn't matter, right? Now we have 10 other numbers. So we've got the 1, the 2, the 3, the 4, the 5, the 6, the 7, the 8, the 9, and the 12 are together. 8, 9 is gone. So 10 and 11. So now count how many circles you've got now. You've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, essentially 11 groups. Okay. Let's see what you guys are saying. Yes, 11 groups. So Nhlanhla says 2 factorial by 11 factorial. Indeed, 2 factorial by 11 factorial. You are quite. Yes, yes. So Letabo, if like a massive number like 20 factorial, we don't have to write down what that is. Okay, absolutely. And 2 factorial by 11 factorial is also, I suppose we could write that down. I mean, it is a massive big number, but I suppose we can write that. What is that? 79 million. Is that right? 79,833,600 ways. Okay, so if in doubt, do what I'm doing here at the bottom with these circles. Okay, and then count them, and that'll help you to get to the right answer. Okay. Oh, I didn't look at Pumzile and Lindelwa's answer. Hold on a second. Okay, so Pumzile said 2 factorial by 10. I think, so the 2 factorial is correct. Then the 10 factorial, I'm guessing, was her counting how many others she had outside the group. Maybe she counted the group again. I'm not sure. Okay. I'm also not 100% sure about their answers. Okay. But don't worry, Lesejo, we've got the right answer here. It's 2 factorial by 11 factorial. Do you understand that? Does that make sense to you? Okay. All right. Okay. Now they've told us they've taken the numbers 1, 4, 5, and 8 out of the box. Okay. So 1's gone. Okay. They're not saying that 9 and 12 need to be arranged together as a group anymore. So maybe what we should do is put them back in place. We can slip 9 in over here, and we can stick 12 at the end. Okay, so what are we taking out? 1 and 4 and 5 and 8. Okay. And now they say to us, 2-digit numbers must be formed out of the 4 numbers. 1, 2, 3, 4, 5, 6, 7. 4 numbers. How many numbers? What do they mean by 2-digit numbers must be formed out of the 4 numbers? Maybe so if you want to form a 2-digit number, you'd have to do that. Out of the, oh, out of those 4. Oh, sorry. I misunderstood. Okay, so what they're doing is that they're leaving the others, and now they are working with the numbers 1, 4, 5, and 8. That's what they mean. Okay, so they've selected these 4 numbers from the group. Sorry, it's not very well phrased. Okay, so they've selected these numbers from the group, the 1, the 4, the 5, and the 8. And now they want to form a 2-digit number. Okay, how many number arrangements can be formed if the digits may be repeated? So in C number 1, it would be, in how many ways can we fill this first box if we can repeat any one of 4 numbers? Exactly. We can fill the box in 4 ways. Then if we're allowed to repeat, then there are 4 ways in which we can fill the second box. So yes, 4 by 4, which gives us 16 ways. All right, not 4 factorial by 4 factorial, 4 by 4, because we can repeat. Okay, so we can't use factorial notation when repetition is taking place. Okay, now the digits may not be repeated. So how many ways could we fill that first block? Digits cannot be repeated. They're different digits. More than that, Kalipa, because you have 4 factorial ways in which you can fill the first block. Yes, we're only dealing with these numbers. Okay, so we've got 4 factorial ways. Sorry, not 4 factorial. We've got 4 ways in which we can fill the first block. Quite right, not 4 factorial. So 4 different ways in which we can fill the first block. And now, if we've used one of these numbers already, we are not allowed to use a number again. We cannot repeat. So it would be 4 by 3. So it would be 12 ways, 100%. Okay, 4 by 3. Okay, does that make sense to everybody? Are there any questions? Yeah, 4 by 3, that's it. Because there's 4 ways we can fill the first block. Once we've chosen a number, we're not allowed to repeat. So that means we've only got 3 numbers left to choose from. We can use the factorial notation, Mbalenhle. I don't know if you remember us doing that the other day, all right? But we can do that, all right? If we say 4 factorial, okay, in the first instance, and we want 4 by 3. 4 factorial means 4 by 3 by 2 by 1. So we don't want the 2 by 1, so we can say 4 factorial divided by 2 factorial. So if we want to, we can use factorial notation. Okay. Because then what we would need to do is divide here by 2 by 1. Okay, and then it will give us the same answer. Okay, so you can use factorial notation if you like. Cool. All right, let's see if we can do an example involving probability before our lesson ends. Okay, what I'm going to do is I'm actually going to do question number 1 because it's a nicer example than that other one over there. Okay, so let's have a look at question number 1. Okay, so now these questions, these questions involve probability. Okay, so it says consider the letters of the word night. Each letter is different. How many letters are there in the word night? Oh, Nhlanhla, I'll go back up. Did you want to screenshot that one? Or was it the previous question, the one about the golf balls? Yes, 6 letters. Not the golf balls. This question that's on the screen now, Nhlanhla. Yes, you got it? Sorry, Nhlanhla, I just wanted to screenshot that. I don't know if the rest of you want to do the same. You're very welcome. Okay. So having a look now at the word night, okay, you're quite right. There are 6 different letters. Now the question says to us, what is the probability that the word formed will start with a K and end with a T? So we've got 6 blocks to fill. 1, 2, 3, 4, 5, 6. Over the total number of ways in which these letters can be arranged with each other. But we'll talk about that now. In how many ways can we fill the first block? It has to start with a K. So in how many ways can we fill that first block, everybody? In one way, quite right, because we're only allowed to have a K that goes in here, and there's only one K. Now we're going to go to the end. In how many ways can we fill this last block? Remember, it has to end with a T. Absolutely. So there is one way in which we can fill that block. 2 of the letters have been used out of this 6-letter word. So in how many ways can we fill the second block here? By 4 ways. And then in how many ways can we fill the third block? 3 ways. Good. How many ways can I fill the fourth block? 2 ways. Absolutely. And then again, I'm only going to have one way in which I can fill the remaining block over here. Okay. How many ways can these letters be arranged with one another? In how many ways can the letters of the word night be arranged with one another? That's it, Lesego. 6 factorial. Okay, so there are 6 factorial ways in which they can be arranged with one another. So the probability of the word starting with K and ending with T is going to be calculated as 1 times 4 times 3 times 2 times 1 times 1 over 6 factorial. Okay, so let's work out what that is. I'm getting 1 in 30. Does that make sense to everybody? Okay, because we're working with probability now. So we have to work out the number of ways that something can happen divided by the total possible number of ways. Are we all good with that? Amelo's got a thumbs up. Akila's happy. Lesego's fine. Good stuff. Yes. All right. And let's have a look at question B. I'll do it over here. All right. Now it has to start with the letter N. So again, there are 6 blocks being filled, but the only you can. Yes, that's fine, Awami. Okay, so it starts with the letter N. The first block can only be filled in one way. There are 5 remaining letters, and they can be arranged in any which way we like. So that would be 5 factorial. All right, divided by the total number of ways in which they can be arranged, that would be 6 factorial. So it would be 5 factorial over 6 factorial. Does that make sense to everybody? So it would be 1 in 6 chance of it starting with an N. That's it. Okay, does that make sense to you all? Are there any questions? You sure no one's got any questions? Okay, so A, le table. Okay, all right. So le table we are filling these blocks with letters. If the word starts with the letter K, there's only one letter K. There's only one way in which we can fill the first block, and that's with the letter K. If it ends with a T, there's only one way in which we can fill this last block, this one over here, and that's with a T. That's why we've got a 1 on this end and a 1 on this end. If the K and the T are gone, there are 4 letters remaining. That's why there are 4 ways in which we can fill that second block. Okay, we can't have any repetition, all right? So that means that if 1, 2, 3 letters are gone, there are 3 letters to fill the third block, 2 letters to fill this block, and only 1 letter that can go in that one. Okay, so Leanne, the difference is here they are asking for probability. In the questions that we did before, they were asking for the number of ways. They didn't ask for probability. Okay, so if the question says count the number of ways in which something can happen, then you're not going to divide it by the total possible number of ways. Okay, whereas here they said, what is the probability? Okay, so remember, probability has to be a number on a scale from 0 to 1, with 0 being impossible and 1 being certain. Okay, so just read the question carefully, whether it's asking for the number of ways or whether it's asking for probability. Are you saying, is it necessary to use factorial in this question? Well, in the denominator, you would have to. In the numerator, if you wanted to use factorial notation, you could get away with it, but it's going to make the numerator a little bit more complicated. But you can write it with factorial notation. That is possible. Okay, so I mean, if you times by 1, it's not going to make any difference. If you've got 4 by, mind you, it's not going to make it that much more complicated. Sorry, it's 4 by 3 by 2 by 1. So I suppose you could, if you wanted, you could write it as 6 factorial over 4 factorial. Okay, Lesejo, there, you could do it that way too if you wanted. All right, it'll give you the same answer.